Hello, fifth graders. Today we're going to go over factors, greatest common factors, least common multiples, and finally intro to decimals. So the first one, factors, it says find all the factors of the following numbers, and we're going to find the factors of 4 and 11. So when it means factors, you have to find the numbers that make it that when you multiply them together, it will equal to 4. So the first thing you should be seeing is that 1 times 4 is equal to 4. And you also know that 2 times 2 is equal to 4. You won't find any other numbers that when you multiply them, it'll equal to 4. So these two are the only ones that will make it equal to 4. That means 1, 2, and 4 are your factors for 4. Because when you multiply them like this, you will make it equal to 4. Now number 3, 11, the only thing that makes sense that when you multiply two numbers together is 1 times 11. So your factors for 11 is just 1 and 11. As you notice, 11 is a prime number. So any prime number you encounter, the only factors for that prime number is 1 and the prime number. So 1 and 11 is all your factors for 3, and number 1, 4, all the factors is 1, 2, and 4. Now the second one we're going to go over is greatest common factors. It says find the greatest common factor of the following set of numbers. Now this is taking use of the previous topic, factors, finding factors of each individual number. So we're going to do number 1 and number 2. So to find the greatest common factor, you have to first find the factors of each of these numbers. So 6. For 6, you can do 1 times 6. You can do 2 times 3 to equal 6, and there's no other numbers that you can do to get to 6. So all your factors is 1, 2, 3, and 6. Now your factors for 9, 1 times 9 works, 3 times 3 works, and there's no other numbers that if you multiply them, it'll equal to 9. So all your factors for number 9 is just 1, 3, and 9. And the reason why I didn't put 1, 3, 3, 9 is because the 3 is repetitive. It's unnecessary to put double of them. Now among these numbers, as you can tell by the name, greatest common, so out of these, the greatest common, so wait, let me circle all the common numbers between 6 and 9, common factors. So 1 and 1 is similar, 3 and 3 is similar, and there's nothing else. Now out of 1 and 3, which is the greater one? 3 is the greater one. So your GCF of C and 9, GCF is an acronym for greatest common factor, is 3. So you got to find the individual factors of each number and then find the greatest common out of them. So let's do 2 and 4. So 2 is a prime number, so you should only have 1 and 2 as your factors. Now number 4, we went over this, should be 1, 2, and 4. Because 1 times 4 makes 4, 2 times 2 makes 4. So it should be 1, 2, and 4. Now I'm going to circle the ones that are common between them, 1 and 1, 2 and 2. So out of this, the greatest one is 2. So your GCF of 2 and 4 is 2. Now the third one is least common multiple, which is an acronym for LCM. It says find the least common multiple of the following set of numbers. So we're going to do number 1 and 3. So this one's a bit different. So we have to find the multiples of each of these numbers. So there's an infinite amount of multiples for each number. So I'm going to start listing them. So multiples is when it goes like 3, 6, 9. So what I'm doing is 3 times 1, 3 times 2, 3 times 3. And then you can guess the next one is going to be 3 times 4. The next one is going to be 3 times 5. And 3 times 4 is 12, 3 times 5 is 15. So that's your multiples. It's basically your number. You're just adding 3 each time. And then it should go on. Now 6 is the same thing we're really doing 6 times 1, 6 times 2, 6 times 3, 6 times 4, and then keep going on. Okay, the 6, 12, 18, 24, 30, 36. Now, and it keeps going on. So as you can tell, it says least common. So the first common number we see here is 6. So since that's the first common multiple we see, that is your LCM for 3 and 6. Now we're going to do the same thing for number 3. It says 3 and 4. So I'm going to find the multiples of this. So 3 multiple is, we already did it above here, 3, 6, 9, 12, 15, 18, 21. So the reason, if you don't find any common multiple between these two, you have to keep going until you find it. Now 4 is just 4, 8, 12, 16, 20, and then on and on. Now the first common thing we see should be 12. So that is your LCM. As I've already said, if you cannot find your least common multiple among these numbers, you have to keep going until you find it. Now the last section is the intro to decimals. It says what decimals are represented by the diagrams. So over here we have models for us. We're only going to go over number 1 over here. So as you can see, there's 100 boxes in here. The concept of decimals is that each individual box is equal to 0.01. So if you have 10 to 0.01, which is this whole column, if you have 10 to 0.01, that will equal to 0.1. And if we have 10 columns at 0.1, so 10 columns at 0.1 means this whole box is equal to 1. Now, what we're trying to represent over here is the red outline over here, and you're trying to write the decimal of this. So really all you need to do is find out how many boxes are being shaded. So there's 10 in each one, so there's 1, 2, 3, 4, 5, 6 columns plus 5. So there's 65 out of 100 boxes being shaded. And you know that 0.01 is each individual box. So that means your column is 0.1, as I said, and if there's 6 columns, that means you have 0.6. And then there's 5 individual boxes, and since each box is 0.01, 5 individual boxes will equal to 0.05. Now you can just add these two, and you'll get 0.65. So decimal representation of this is 0.65. Which also corresponds to how there's 65 boxes that are shaded. Now knowing this, we're going to go over number 5 over here. Now, as I said, this whole box represents 1. So if your whole box is shaded over here, that means we have 1 over here. Now this box is not filled and we're trying to find. Let's see how many are filled. There's 2 columns filled and we know there's 10 boxes in each. So that's 20 already. And then this one over here is 5. So you have 25 boxes that are shaded. So it's 25 out of 100 boxes that are being shaded right now, which is equal to 0.25. If you have 1 over here plus 0.25 over here, if you add them, you should get 1.25. So that's how you represent number 5 in decimal. And that's it for today.